Hello friends, it's Susanna, and today I want to show you how to work with the sigma notation. We go through these 7 examples together. At the end, we even have a double summation, but let's start with the first example here. Write out what is meant by this expression. We have this sigma here in the middle, and every time you have this notation here, you know that this is going to be a sum. So you have something plus something plus something plus something and so on. And then here below your sigma, you have your index. This is our letter K here, but it could be any letter, but it says our index is going to be K, and we start with K equals 1 and go up to K equals 4. So we have the summation from 1 to 4. And everything we do, we start with K equals 1. So our first part here of the sum is going to happen with K equals 1. Then the next part, we will increase our K by 1. So our next K is going to be 2. For the next part, our K is going to be 3. And for the next part, our K is going to be 4. And this is going to be the last part because here the sum says go up to 4, but then stop. So these numbers here are for your K from 1 to 4. And at the beginning, you can write down these things so that you have in mind, okay, right now I'm in the first part, my K equals 1. Then I'm going to be in the second part, my K equals 2, and so on. And then you have the heart of your sum. This is what will repeat. And here in this thing, you have to search for your K. Your K is here. K is going to change. Everything else, really everything else that is not K will stay the same. So for our first part, we know that K equals 1. So we look into this thing here. We don't change anything that is not our K. So we leave the X as it is. And for K, we insert 1. Done. Next part. Our K equals 2. So we look into this thing here. The X is not our K. So we write down the X. And for the K, we insert 2 this time. Then we have a plus. Next part, same thing. The X will stay as it is, and for our K, we insert the 3 this time, plus, and then you might know what comes next. The X stays the same, but our K equals 4 in the last part. All of this was just to help us, but this here is the result of this expression. You can simplify it a little bit, so x to the power of 1, you don't have to write the 1, but everything else looks good, and this is the result of number 1. Number 2. Write out what is meant by this expression here. Okay, we're more familiar with this now. We know we have a sum here. This time our index, the letter here, is an I, not a K. It can be any letter, but we will look at an I then. It starts at 1 and goes up to 3. So my first part of my sum is going to be with I equals 1. Then I increase my I, go up to 2. Then I increase my I by 1 and go to 3. And this is where I stop. Then I have the plus symbols in between. I start with I equals 1. I go to the part here inside and I take a look at where my I is. This I is going to change. Everything else will not change. So for the first part, my I equals 1. So for the I insert 1. And then I have the square here, so I have to write the square. And this is it for the first part. Then I have my plus. My I changes to I equals 2. So for the I insert the 2. And then I have the square here. So I write this down. That's it. I make a plus. And then my I equals 3. So instead of the I write a 3, and I have my squared. Don't forget the rest of it. Just write down everything else. But this is my sum, so this was just to help me. And now I can calculate this. 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. So in total, I have a value of 14. My sum equals 14 if I just evaluate this. Number 3. Write out what is meant by this expression. Same thing. First of all, we have a sum here, which means that we will sum things up. Our k starts at 6 this time. Okay, no big deal. And we go up to 9. So my first index k starts at 6. Then k is going to be 7, k is going to be 8, and at the end k is going to be 9, and that's it. That is where I stop. Let's start with the first one, k equals 6. I can select every k that I have here. Here's a k, and here is a k as an index. Everything else will not change. So I have 6 for the first. 6, I insert that, times x stays as it is, but the k, we will insert the 6. So I have 6x6 at the beginning, plus my k increases by 1. My k equals 7 now, so I have 7 times x stays as it is, but my k equals 7, plus my k increases to 8. I have 8 times x, and instead of the k, I write an 8. And the last thing, for my k, I write a 9. The x stays as it is, but don't forget the index 9 here. So this is what this really means. Next example. What's happening here? I still have a sum. My index is called k. It starts at 1 and goes up to 3. So I can start with k equals 1 to help me, k equals 2, and to k equals 3, and this is where I stop. Okay, so my first part, k equals 1. If I take a look at my sum here, there is no k in here this time. But we do the same steps. We start at k equals 1, and for every k we can find in here, we insert 1. There is no k? Okay, no big deal. We just take everything else that is in here, so it's just the 6, and we're done with the first part, and we're going to add the second part. Our k equals 2 this time. There is no k in here that changes. Okay, no problem. We just take anything else that is in here. It's just the 6, so we add it. And plus, we go to the next k, which equals 3. Still no k in here. We don't have to change anything. Just take the 6 here in this example. This was the last k, and now we only have to add these numbers. 6 plus 6 plus 6 equals 18 then, and this is our result. Next example. The sum from k equals 5 to 5. This time our index starts as 5 and ends at the same number. So my first thing here is k equals 5, and I cannot increase my k because then I would be at a 6, but this already tells me just go till you're 5. So you only have this one step to do. Your k is just 5, and then you are already at the end of your sum. Okay, then let's just do this. We have a k in here. At the first part, my k equals 5, so I insert the 5 here. I have 7 times 5 then. That's all I have to do, and I can calculate this. It's 35, and I am done. Next example. This time we have more things here in our sum, but the rules are the same. We take a look at our m. It starts at 5 and goes up to 7. Our m is in here and in here, and we are going to insert 5 at the beginning for each m that we can find. So we have 5 squared first minus, and for this m we also insert 5, so minus 5. You can write the parentheses if you want to. You don't have to, but at the beginning maybe it's clearer that this is your first part, and then we're going to add our second part. Our m will be increased by 1, so m is going to be 6 now. So we have 6 for our m squared minus, for our m we insert 6. We close the parentheses and come to our last part, because m is going to be increased again to 7. And we have 7 squared then minus the 7, and this is where we stop. And now you can calculate this. 5 squared equals 25 minus the 5 plus 36 minus 6 plus 49 minus 7, and if you calculate all of this, you get a result of 92 for our sum. And the last example, we have a double summation here. And this looks probably more complicated than it actually is, because the rules are the same. We just have to know where to start. We have this first sigma symbol and the second sigma symbol. So we have this outer sigma symbol and this inner sigma symbol. And you always start with your inner summation first. So you can also write this second sum here in parentheses if you want to, and you would start with this summation first. That means that you can just take the first sigma and just write it down as it is without changing anything. And then we start with this summation first, which means that our k equals 2 first. We go up to 3. Our k in here is only here, so this is what is going to change. We write down everything else as it is. You can write down the rest here in parentheses if you want to. So we start with k equals 2. We have 2 times, instead of my k, I write a 2. Then I have the plus I. I don't change anything, I just write it down like this. This was k equals 2. Now I increase my k. We go to k equals 3. This is also the end then. So I add a plus, and now I insert a 3 for my k. So I have 2 times, instead of the k, I write a 3, and then I have the plus I here. I can close the parentheses. This was my help. And now I'm going to simplify this inside the summation first. So I write down the sigma symbol as it is, and in here I have 2 times 2, which equals 4. I have 2 times 3, which equals 6. So I have 4 plus 6, which equals 10. And I have I plus I, which equals 2i. I can write this in parentheses if I want to, and then I take a look at my outer summation now. My index has changed. It's an I now. So my I starts at 1 and I go up to 2. My I is in here, so I start with I equals 1. I have 10 plus 2 times, and instead of the I write a 1. And then I come to my second part of the sum, so I add this plus. My I is increased. I have I equals 2 now, which is also going to be my last part. So I have the 10 in here, plus 2 times, and instead of the I am at I equals 2. And now I just have to calculate this. 10 plus 10 maybe first equals 20 already. Then I have 2 times 1 equals 2. I have 2 times 2 equals 4. So in total I get a result of 26. And this is how you work with the sigma notation. I hope it helped you. If you have any questions, please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!